Yes, quite.
The light out here, it's just perfect.
I thought this might look ridiculous, but it's actually kind of perfect.
It wasn't supposed to end like this.
其实，我一直都在这里等你。
You look like a giant marshmallow.
Excuse you, it's called fashion.
这世上伎俩多了，你找错门了吧？
今天这里的光线太完美了。
太伎俩，起来，今晚的年，你是想在这里过，还是想下山去和那些凡人
？After Wan stopped open sourcing new versions, LTX 2.3 became the newest and most powerful open source video generation model available, and the open source community has produced extensive fine-tuning around it. Back in the Wan 2.1 era, we had FusionX, which offered better performance and results. Now in the current stage, we of course also have fine-tuned versions of LTX 2.3. In today's video, I will introduce several fine-tuned models based on LTX 2.3, each with its own unique characteristics and worth trying. Start with Sulfur 2. It was released by the Sulfur AI team with the core developer being FusionX. The team has always focused on three directions: completely removing content censorship, improving anatomical accuracy, and achieving cinematic dynamic performance. Based on LTX 2.3, Sulfur 2 is the team's latest release. The most obvious advantage is the absence of content censorship. It can generate NSFW content. However, we certainly won't be showing that part in this video. Interested viewers can explore on their own. Beyond that, it also improves body motion handling, character facial consistency, cinematic dynamic performance, and prompt adherence. Even if we only run conventional content, it's a worthwhile enhanced model. Sulfur AI officially provides multiple versions. The first is the full dev version, available in two formats, a 46.1 GBF16 format or a 29.2 GFP8 mixed format. The second is the distilled version, available only in a 46.1 GBF16 format, which is quite large and difficult to load on consumer-grade GPUs. There are also function LoRa's designed to be used with the original LTX 2.3 model, as well as a dedicated distillation LoRa. The community also provides GGUF quantized versions, and you can choose based on your VRAM capacity. For example, the Q6K model here is only 17.8 G, which can even run on a machine with 12 G of VRAM. In addition to these standard models, there is also a prompt enhancement model based on Qwen 3.59B in GGUF format. It's a large language model that can generate high-quality prompts through conversational interaction. I'll demonstrate its usage later. One thing to note, the large model should be placed in the checkpoints directory, GGUF models go in the diffusion models directory, and all LoRa models go in the LoRa's directory. Start Comfy UI and load the LTX 2.3 text-to-video two-stage workflow. The first stage uses the full model to generate a half-size video as the base, and the second stage loads the distillation LoRa for upscaling and detail refinement. Sulfur 2 is used in almost exactly the same way as the original version, with minimal migration cost. Simply replace the original model with the FP8 mixed version of Sulfur 2, swap the LoRa to the officially recommended distilled version, keep all other parameters and nodes unchanged, and run directly. After waiting about 4 minutes, we get a 1080p video like this.
The lighting here is absolutely perfect today.
The overall quality of the result is completely solid. Clear image, natural lighting, reasonable composition, and good retention of details like facial features, hairstyle, and clothing. Compared to the original LTX 2.3, each has its own merits. I personally prefer the cooler cinematic tones of the original version, but this may also be related to random seed differences. Some viewers may not have downloaded the original LTX 2.3 large model. However, in the current workflow, the audio text encoder and audio VAE are still loaded from the original LTX 2.3 large model. So running it directly will cause an error because the model can't be found. But actually replacing everything with Sulfur 2 models works fine too. Change it and run again. Video generation is complete.
The lighting here is absolutely perfect today.
At first glance, they look very similar. Compare them with a professional tool. Using the difference comparison mode, it calculates the absolute difference of RGB channel values at the same pixel position between two images. At a threshold of 30, the result is almost a black image, indicating that the actual results are highly consistent. So if you like the Sulfur 2 style, you can absolutely just download this one model and be done with it. If you already have the original LTX 2.3, you can also just load the Sulfur 2 function LoRa to try it out. Switch the model back to the original version, load the Sulfur 2 LoRa in the first stage, and pass the merged model to the second stage for reuse. Generation time remains around 4 minutes and the overall quality is good.
The lighting here is absolutely perfect today.
But personally, I feel the audio clarity is slightly inferior to using the full large model, with some scenes having overly strong ambient sound. If conditions allow, prioritize using the full large model, which is the checkpoint file. Sulfur 2's official team also provides some workflow examples. Their parameters differ from our workflow defaults, mainly in sampling-related settings. Restore the workflow to the large model state, then switch to the official workflow parameters. The first stage has 50 steps with the Euler sampling method. The second stage uses the LCM sampling method. Click Run. Actually, the Sigma settings are also different between the two stages. However, I tested multiple scenarios and found basically no difference, so I'll take a shortcut and not change this parameter. Although the first stage runs 30 more steps, since it's the low resolution stage, the total time only increased by less than 1 minute.
The lighting here is absolutely perfect today.
The final result is still excellent. I don't think there's a fundamental difference in video quality, so there's no need to specifically switch to these more complex and time-consuming parameters. Restore the workflow to its original parameters. Now try the speed mode where both stages use the distilled model. This mode is also very popular when using the original LTX 2.3, especially suited for those who prioritize generation speed. In the first stage, load the Sulfur 2 distillation LoRa with a strength of 0.7, change CFG to 1, and adjust the steps and sigmas according to the official recommendations. Keep the second stage unchanged and click Run directly. Because the first stage reduced steps from 20 to 8, a reduction of more than half, the overall generation speed improved by over a minute. The final result looks like this.
The lighting here is absolutely perfect today.
Theoretically, visual diversity and the preservation of extremely fine textures will be somewhat weaker. But in many cases, this quality is already more than sufficient. The balance between speed and quality is quite good. However, I care more about quality than speed, so switch the first stage back to the dev full model. In my previous LTX 2.3 video tutorial, I mentioned that you can make characters speak Chinese just through the prompt. And to get more standard Mandarin pronunciation, it's best to keep the overall prompt in English and only change the specific spoken content to Chinese. Now test how Sulfur 2 performs in this regard. Only modify the positive prompt, keep all other settings unchanged, and click Run. The results are almost identical to LTX 2.3. Video generation works normally, and the character's Chinese pronunciation is clear. When generating Chinese videos, the character's face also has more Asian features. However, the drawbacks are also fully inherited. These chaotic error subtitles directly ruin the entire video. Don't worry, later in this video we'll explain in detail how to remove these subtitles with a success rate close to 100%. When introducing the models earlier, I mentioned that Sulfur 2 also comes with a prompt enhancement model. It doesn't require additional system instructions, just chat with it directly to generate high-quality prompts that are better suited for the model. Try it out. This model is in GGUF format and also requires an mmproj file to enable multimodal visual understanding. The officially recommended simplest method is to use LM Studio. Create a new folder, place the model file and mmproj file inside, then load it with LM Studio. Select this model to start a new chat. Enter a simple prompt, a girl running in the rain, and you get the following detailed prompt. The scene information is more specific, the actions are clearer, and the visual style is noticeably enhanced. By default, this model outputs Chinese when given Chinese input, and English when given English input. Back in the Comfy UI workflow, paste this prompt directly into the positive prompt and click Run. The prompt itself looks decent and has a strong sense of dynamism, but I don't really like the final generated video. For text-to-video, I still prefer using my own system prompt. Sulfur 2's low migration cost is also reflected in its good compatibility with most LoRa's trained on LTX 2.3 or even LTX 2.0. First, restore the prompt to the girl holding a camera on the street, then load a Ghibli-style LoRa in the first stage. Don't forget to add the LoRa's trigger word at the very beginning of the prompt.
The lighting here is absolutely perfect today.
In the final generated video, the Ghibli style is very pronounced, and the LoRa produced great results. However, in the last frame, the character's fingers have some issues. Looks like we still need to roll a few more times. Compared to text-to-video, I personally prefer image-to-video. It provides extremely high certainty, greatly reducing the need for repeated generation. It can also achieve very strong character and scene consistency by using text-to-image or image editing to produce the first frame. The prompt only needs to focus on actions and changes, which significantly reduces difficulty. Load the LTX 2.3 image-to-video workflow I shared before, and switch the model to Sulfur 2's FP8 mixed large model. Upload a portrait of a girl in a school uniform. The prompt is simply the girl is saying, "I see you" in the second stage. Also switch the distilled model to the Sulfur 2 compatible version. Keep all other settings unchanged and run.
I see you.
The video is indeed very stable. Character movements are natural and smooth, especially the stability of the finger pointing and eye contact. When saying "I see you," the lip sync is also quite precise. The prompt just now was generated using my system instructions. Now back to LM Studio to try the prompt enhancement model. Drag the image into the chat box, enter "The girl is saying, I see you," and the model quickly returns a prompt. Copy it. Comparing the two prompts, my system prompt focuses more on cinematic feel, camera movement, and detail control. The prompt enhancement model's version has a style that's brighter, fresher, and more Japanese school life oriented. The descriptions are more concise, but with fewer camera movement details, and the overall atmosphere is more lighthearted and playful. Now switch to this new prompt in the workflow and see the effect.
I see you.
The style is completely different. This version has a brighter overall image. The girl's smile is sweeter and more lively, and the atmosphere is more relaxed and cute. But the camera push-in effect isn't as pronounced as before, and the cinematic feel is relatively weaker. Since image-to-video results are so stable, would using distilled models in both stages offer better value? Enable the Sulfur 2 distillation LoRa in the first stage with a strength of 0.7, and adjust CFG, steps, sigmas, and other sampling parameters to the official recommended values. The second stage doesn't need adjustments. Run directly.
I see you.
Generation speed is indeed a bit faster, and overall quality is fine. Character facial consistency, movement fluidity, and lip sync are all good. However, in the last frame, there's a slight deformation in the hands. Personally, I still wouldn't sacrifice quality for this small speed gain. That covers Sulfur 2. Now take a look at another large model, 10 Eros. This model's creator is Tenstrip. It's a merged model built on top of Sulfur 2, specifically crafted for extreme image-to-video use cases. It effectively addresses common issues like models not following complex instructions and unstable multi-character interactions. The model repository only has 3 models, BF16 and FP8 mixed full versions, and a transformer-only FP8 split version. I suggest viewers with sufficient VRAM above 12G use the FP8 mixed version directly. This version is a 3-in-1 large model that includes the audio text encoder and VAE. it's the simplest to load, with the same experience as the original LTX 2.3 and Sulfur 2. If your VRAM is limited, you can choose the community-provided GGUF quantized version, but you'll need to separately prepare the audio text encoder and VAE. Beyond releasing the model, this creator also specifically developed a Comfy UI plugin called Tense Comfy Nodes. It enhances identity preservation, latent space stability, and quality improvement during the upscale stage. It's especially suitable for video generation that requires high consistency and complex motion control. However, the example workflow provided by the creator is quite complex. I made a few optimizations and simplifications, and here is the tidied-up workflow. Load the FP8 mixed format large model. The input image is still the same schoolgirl from earlier. Pay attention to the prompt. 10 Eros is very sensitive to prompts. If you don't explicitly specify actions, it will mostly keep the character still. But don't worry, the creator provides a system instruction, and we can have a multimodal large model help us generate high-quality prompts. The entire workflow uses dual distillation. The distillation LoRa is already loaded in the first stage's sampling. Note that, just like Sulfur 2, it's best to use a separate dedicated distillation LoRa. In the sampling stage, you can also see many nodes with complex parameters. These are from the Model Creator's plugin, which deeply controls the sampling process. Just keep the defaults. The second stage loads the distillation LoRa and the upscale model. Click Run. When actually using this workflow, you only need to focus on the input image, prompt, and main parameter settings. I recommend keeping all the sampling section at defaults.
I see you.
This video's overall quality is good. Motion continuity, subtle expression changes, and the I see you lip sync are all very stable. It also maintains the same overall style as the input image without drifting toward a Western art style. However, the actions in this prompt are relatively conservative, and the camera is fairly static. I switched to a new image to challenge more complex movements and multi-stage performance. This time the input is an image of a girl wearing a white knit cardigan with bunny ear accessories. I wrote a very detailed, structured prompt, having her complete a full performance sequence, hold initial pose, speak lower hands, change pose, continue speaking, and finally adjust.
I thought this might look ridiculous, but it's actually kind of perfect.
I'm very satisfied with this generated video. The motion continuity is excellent. From holding the bunny ears with both hands to lowering hands to her waist, to slightly shifting weight to sway the skirt, to finally adjusting an ear, the entire multi-stage action transition is natural, with no noticeable stuttering or clipping. Most importantly, the model strictly followed the prompt, executing the actions, expressions, dialogue, and camera movements step by step exactly as I designed. Its instruction following ability is very strong. Going one step further, I changed the initial image to a two-person image. I also wrote detailed prompts for both characters' interaction process, continuing to test 10 Eros' performance in multi-character scenarios. Although the input this time is a horizontal image, the workflow adapts automatically without needing any modifications. The final video looks like this.
You look gorgeous. Stop it.
Both characters' face shapes, facial features, hairstyles, and clothing details remain highly stable throughout. Interactive movements are natural and smooth, expressions and lip sync are well synchronized, and detail control is solid. It strictly follows the prompt, fully executing the multi-stage interaction requirements of turn head, dialogue, physical contact, and return to camera. Regarding multi-character scenarios, I've been running short dramas recently, so I've done extensive testing. Over 80% of the control is very stable, but there are also some issues that require repeated generation. When the characters in the input image are not large enough or their faces aren't clear enough, lip sync issues tend to occur. Sometimes there's sound, but the mouth barely moves. When two characters are quite similar, such as two seated women in this image, the prompt mainly distinguishes characters by left and right positioning. Overall movements are reasonably stable, but if you have both characters speak separately, it's easy to get character correspondence errors. For example, the person on the left speaks the right person's line. Overall, though, 10 Eros is already one of the highest precision control solutions for multi-character interaction scenarios, and is currently the most powerful image-to-video model. Beyond Sulfur 2 and 10 Eros, there's also an ICEdit-Insight model based on LTX 2.3 that's very practical. It's positioned as a task-aware video restoration and editing model. The official demo showcases 4 core functions: video restoration, video high-definition enhancement, watermark removal, and subtitle removal. The repository has released a total of 5 models. One is the FP8 large model, and the other 4 are task-specific LoRa's. According to the officially recommended workflow, you actually only need to download the corresponding LoRa to use it. First, demonstrate the most practical feature, subtitle removal. Load the workflow I organized based on the official process. The large model uses the official LTX 2.3 base model, loads the distillation LoRa at 0.5 strength, then uses the IC LoRa load node to load the subtitle removal LoRa. The image input setup is a bit convoluted. The core idea is to generate a pure white image with the same dimensions as the original video, adjusted to be divisible by 8, and pass it as input to the sampling node. I uploaded a video of a character speaking Chinese that was generated by LTX 2.3, which contains obvious error subtitles. For the positive prompt, directly use the one provided by the official team, which is to remove subtitles. Keep all other parameters at default and click Run. The video is generated quickly.
今天这里的光线太完美了。
And the subtitles are cleanly and thoroughly removed, with virtually no visible residue. Continue comparing with a professional tool
今天这里的光线太完美了。
To more intuitively compare the effects, I use the difference mode.
今天这里的光线太完美了。
You can see that apart from the subtitle area showing obvious red differences, the changes in other areas are very minimal. In my experience for subtitles in videos generated by LTX 2.3, this LoRa achieves nearly a 100% removal rate. Very stable. Next, test the watermark removal feature. Use the same workflow, just switch the LoRa to the dedicated watermark removal LoRa and change to the corresponding prompt. This time I uploaded a video generated by Gmang AI, which has an AI-generated label in the upper left corner and a Gmang watermark in the lower right corner. Click Run directly. This workflow also supports adaptive input video dimensions, so no extra adjustments are needed. The final result looks like this. At first glance, the watermark removal effect is quite good, with almost no visible residue. But compare with a professional tool. Switching to frame mode, you can clearly see that in the first frame, both watermarks are still present. In the second frame, the watermarks have noticeably faded and shrunk. By the third frame, they're basically completely removed. I've tested multiple different videos, and watermark removal performance generally shows weaker results in the first 1 to 3 frames, with clean removal in subsequent frames. Perhaps the workflow could be adjusted to optimize this. Also, if the original video quality is very high, we'd need to perform HD upscaling on the watermarked video afterward to match the original video's detail. Some stubborn watermarks can be combined with the subtitle removal LoRa for better results. One of LTX 2.3's greatest advantages is how easy it is to fine-tune. Combined with the convenient IC LoRa framework, the community has already produced many excellent fine-tuned large models and LoRa's. For example, the Dasiwa series focused on high-quality realistic style, the VBVR LoRa that significantly improves motion stability and video logical reasoning, the InPaint LoRa specialized in local repainting and restoration, the official lip-sync LoRa, and more. Due to time constraints in today's video, I won't demonstrate each of these models one by one. If there's an opportunity in the future, I'll create a detailed tutorial combined with specific use cases. Flexibly combining these models and LoRa's can effectively address common issues with the native LTX 2.3, such as last frame collapse, visual subtitle hallucinations, and motion blur. Alright, that's it for today's video. If you found this content helpful, please give it a like to show your support. All models, plugins, and workflow download links mentioned in the video are in the description. Feel free to grab what you need. See you in the next video.